When you're solving log equations, there are two things you need to keep in mind. So let's look at the course review number 13. If you have a log equation that just contains one logarithm, you approach it one way. But if you have a log equation that contains two or more, you approach it another way. So those are the things to look for, whether it's just one log expression in the equation or more than one. So let's look at A. This has just one log expression in the equation. So I don't need to combine things because I just have one logarithm. So I can just simply express that as an exponent. I want to rewrite that so that if I rewrite this as an exponent, so I have base 2 and then exponent 4 equals what's inside the logarithm. So rewriting that log as an exponent got that variable x out of the inside of the log equation, so I can now solve for it. So this is 16 equals x minus 5, x equals 21. So now let's look at the second equation. I have two log expressions in here, so I know I need to use those properties of logarithms because my ultimate goal is to just have one logarithm in my equation, so I can do what I did here and rewrite it as an exponent. So log base 2 pardon me for this is going to take a second, but it's a lot easier to read than when I write on the screen. And then, so I'm typing in my equation. So log base 2 of x squared plus 1 minus log base 2 of x plus 2 equals 1. So here I need to combine to make one logarithm. So I'm going to use that quotient rule that says that the difference of two logs of the same base can be re-expressed as the log of the quotient. So the first log is my numerator, the second log is my denominator, and the right side of my equation did not change. Now I'm going to re-express it as an exponent because now I only have one log expression. So 2 to the first power equals what's inside the logarithm. So now I have a rational equation, and I can just solve that like I do any rational equation. So I'm going to multiply both sides by x plus 2, so I can get rid of my denominator. And I like to copy and paste if you can't tell. And now I'm left with a quadratic. So that's the thing about this class, like almost every problem we do boils down to a quadratic. So if you don't know how to solve a quadratic, you're kind of sunk in this class, but I think most of us know how to do that now. So I'm moving everything to one side because when I solve a quadratic, I set everything equal to 0. I need to fix that. So I bring the 2x over, the 4 over, and now I have an equation equal to 0. So I'm going to combine like terms. And I'm going to factor. Of course, if this didn't factor nicely, I'd use the quadratic formula. And I get x equals 3 and x equals minus 1. So anytime you use a identity like you did here, you want to check your solutions. And the real reason I want to check my solutions, when you multiply, like when I went from this step to this step, and I multiply both sides by x plus 2, when you multiply by the variable, you need to check for extraneous answers. So we're going to check. So I'm going to enlarge my screen here. So I'm going to plug 3 and minus 1 into my original equation. So I'm going to copy and paste it if I can grab it. When you're making a video, the video software sometimes makes life difficult. Alright, so I'm going to copy and paste that down here. So now this would be, if I substitute 3 in here, I get the log base 2 of 10 minus the log base 2 of 5. Well, I know that using that quotient rule, that's the log base 2 of 2. And I know that log base 2 of 2 equals 1. So that checks. And then I'm going to try my other solution, x equals minus 1. So minus 1 squared is simply 1. And if I plug that minus 1 in here, I would get the log base 2 of 2 minus the log base 2 of 1. So let's see what that is. So the log base 2 of 2 is simply 1. And the log base 2 of 1, remember, anything, the logarithm of any base of the number 1 is always 0. Because 2 to the 0 power is 1. So this checks too. So both of these solutions work. And I'm going to go back to my course review. And that is how you would solve these two log equations.